start with the one thing, one molecule, go through the reactions, you are getting two products. So how that happens? So in order to understand that, we got to go through the mechanism, and then showing the mechanism is actually what this question is asking. So let's look at what we are dealing with. We have an alkyl halide. I mean, having an alkyl halide does not mean that it's going to go through SN1 reaction. Right? SN2 reaction also uses an alkyl halide too. So this is some of the things that we need to talk about later. But what we need to see here, this alkyl halide is reacting with ethanol. And then ethanol is an alcohol, neutral alcohol, and that is not a good alcohol. That's something that we talked about before. If you're not so sure about these things, strong alcohol, if you drink it, you die. And of course, you can die if you drink too much alcohol. That's not what we're talking about, right? This is something that we can sometimes get happy with it. This is not a strong alcohol. So one thing that you gotta keep in mind that in order to make an SN2 reaction go, is a requirement. You have to have a strong alcohol. And this is not a strong alcohol. So what that means is SN2 reaction is not the one happening. The only thing that can happen right now is an SN1, because we only talk about two reactions. Later on, you need to think about eliminations. There's a full possibility show up. You have to figure out what reaction will happen by looking at two of the reagents. So that's going to be really the hard part. We're going to get into that. But right now, you need to figure out just the two reactions, which one will happen. Strong alcohol is a requirement for the next two reactions, and also statically non-hydrogen. But in the case of this weak alcohol like this, what I'm expecting is an SN1 chemistry, meaning that this halogen chlorine is going to come off the molecule with electrons. So we're going to make the chloride meeting. And that needs a carbocation where it binds, which is this portion right there. That's a secondary carbocation. Secondary carbocation can go through the reactions. And that may be showing this product too. So if you got the solvent molecule, comes and attack this carbocation before they go for the rearrangement, right? Then that explains why these things happen. You got the oxygen of the alcohol attack this carbocation, it becomes a protonated form, but proton goes away to solvent easy, and you get these products. So these products here is a product of the SN1 reactions from the carbocation initially produced. But we just talked about if there's a more substituted position next to this carbocation, we can expect this hydrogen move there and making more substituted carbocation form. And that is a rearranged carbocation, right? And then that's a secondary carbocation after this hydrogen move or the hydride shift. This is kind of symbolized like this. Then you get the tertiary carbocation, which is a kind of more stable. So we are expecting this rearrangement will happen. So once the secondary carbocation, this secondary carbocation will for the reaction making that, but it will go for the rearrangement too, making another carbocation. And now this carbocation can capture the nucleophile. Then this oxygen of the ethanol connected to the tertiary positions. When the proton goes away, you get this product. So that kind of explaining rearrangement is actually happening. And because of that, you get two products forms. This is not asked in this question, but we can also talk about which one of these two are going to be the major product. What do you think? Which one will happen more? This one or that one? So bottom line is, the more stable intermediates will speed up the formation of the product because it will get formed faster. Obviously, this has to be formed first. But once they become this molecule trying to looking for any way to get rid of it, rearrangement will happen fast. It's not saying that it's not there. It is there. If the solvent come and capture these things before it get released, then that's what it forms. The majority will go through here to get more stabilized, and then eventually it will get there. So I would say that this will be the more major products because it comes from the more stable carbocation rearrangement. It takes time, and it can be kind of fast enough to make it happen before the capture by the solvent. So that is the reason why I think that is a major problem. The question could be, I can probably ask, give me all the products. Regardless how little chance it gets, there's many possible ways to form multiple products. Right? That's one way I can answer you. Another way I can also ask you is, give me the one major product. I don't care how many forms, give me the one major product. Or I can even ask a question like this. I can give you the products from the study materials and explain why this is out. It's like giving the mechanism, drawing out the mechanism. Then you got to draw all these things. I know that's kind of a things that you have to explain. Reactions are, arrows, and then showing the word electron moves and transformation that way. And that's the mechanism. So you can expect the question from those way. And of course, I can give you this, I can give you that, and then I can ask you to give me what type of reagent will make it up. So there's so many different ways to make a question here. So whenever you solve the one question, think about other way the question may be converted to. One way, if you study as a group, you can challenge each other. You can make the question on your own. Sometimes you become in my shoe, then you're gonna see that what type of question I would probably make to torture you. If you practice that, you kind of know what topics are more important, and then you can challenge each other. I hadn't suggest. It'll be good to see on in my shift. Sometimes you have that will give a very fresh perspective. I'm not asking many things. I'm not asking a simple thing because that would be making everybody, which sometimes we do. Often cases we make the question really harder to make you understand this properly. Then it can sort of twist the question this way that way. If you exercise it, you may see what way you need to see the reactions. Anyway, those kind of suggestions here. Sometimes a really odd transformation happens because of that, the rearrangement. But this explains that. So we started from this one. And then this is iodine, not just directly substituted. That also we can expect when it's naturally here. It shows the two other products which is not exactly relevant from the one we studied. One is better, yes, because they still have these things similar. So you can see that why these things happening. But what about that one? Why change to something different? Very different. So this is kind of what I'd like to explain to you. As I said again, this is alkyl halide. Alkyl halide is a substrate for the SN2, SN1 reactions. But if you look at that, this is an ethanol again, the solvent, which is a non-neutral. So SN2 reaction is not going to happen with it, even though this is a really good substrate for the SN2 reaction. So what will happen is iodine, it's a molecule is basically waiting until this iodine blows out as an iodide. It's not happening spontaneously. That's why it's going to take time. SN1 reaction is not a fast reaction. SN2 can be really fast. It can be like 1 second, 5 seconds, 10 seconds, even sometimes a minute. Really fast. SN1 takes hours, takes days, because it has to create a carbocation, which is much unstable. Doesn't happen spontaneously. But slowly, some part of the molecule, even though this is terrible, the Boltzmann distribution, if you learn from Gen Chem, mean that some of the molecule will have enough energy to go through this. So this is happening through that process. Not everything, but small fractions. Losing this iodine goes out as an iodide, you can imagine that forms carbocation. And this is a primary carbocation. Very terrible. This is really bad thing. Yeah, tertiary carbocations is good. Secondary, yeah, I can see that. But primary is a really terrible. This is not really going to happen well. So I imagine that once that forms, the adjacent hydrogen is immediately flying, because that's the only way it can get stabilized. And then luckily, it has a hydrogen, the tertiary position right next to it. So hydrogen move out, that's a rearrangement, right? And then you get the tertiary carbocation forms, which is way better now. So good. That's the what I imagine happening really fast once initial carbocation forms. And that tertiary carbocation captured by the solvent molecule as a nucleophile will make this. So that one can be explained very easy. I know it goes through the rearrangement to do that, but yes, but at least it can be expected, it can be explained. But what about that one? How come that happened? We have a 6-member ring cyclohexane there. Do we have a cyclohexane there? No, cyclohexane is gone. So how come the 6-member carbon ring is not there anymore? If you actually count it, that's actually a 7-member ring. The ring got opened up. So how come 6-member ring changed to 7-member ring? Right? That is something that I've explained to you. So if you remember that, the rearrangement involved some atom in the adjacent carbon moving a position. Hydrogen is very small, very easy to make it happen, but carbon can also move too, which is a sluggish, but it can happen. Carbon, if this carbon moves, not only this carbon moves, this carbon carry all the chain. You have to think about that. So what happened was, when this carbon moved, making this bond, that is bond that made it, and this bond is getting broken, right? So you get this carbocation bond. That's a primary carbocation where we studied it. Primary carbocation, making the hydrogen move, becomes a tertiary carbocation going this way. When this carbon moves, then it will make a secondary carbocation. And because of this carbon make a bond with that, now it becomes a 7-member ring. So if I draw that one neatly, it makes a 7-member ring. Carbocation just moved this here to there because we are making a bond between these two, and this bond is getting broken. That's why the carbocation goes there. So this carbocation captured by the solvent molecules again, then you get that produced. So that is also the products of the carbocation rearranged. Yeah, so that's what I'm getting to. So anyway, these two happens. One rearranged, hydrogen rearranged. The other carbon rearranged, carbon rearranged. Between these two, if I'm asking which one's going to be major product, I'm expecting this as a major. One, hydrogen is much faster to move, and then that makes a more stable tertiary carbocation. And the method of moving out is much slower. It only makes a secondary carbocation. So this is probably way better than the other one. So I'm expecting this is a major product, but that we can expect to see maybe a small amount. So it could be a minor product.